So now we're going to deal with rate of work problems. So the whole idea between rate of work problems is you have usually two people doing the same job, and we use person one. I'll put some. We have person one can do it at a certain rate. We're going to add to that person two, and we have the whole job is what we're looking at. So this is going to be key. How long does it take for both people to do the one job? So if I look at number one, it says Julio can fill a water tank in 4 minutes using a large hose. He takes 6 minutes using a smaller hose. How long does it take if he uses both? So we have two different rates at which they can do the job. Again, their rate of works. One is 4 minutes, the other one is 6 minutes. So what we need to consider is, how long does it take this hose, how much of the job can they get done in 1 minute? Not 4 minutes like it says, but how much of the job can they actually get done? And so if we break the job up, here's job, he can get 1 minute, 2 minutes, 3 minutes, 4 minutes, and in 1 minute, he can get 1/4 of the job done. We'll do the same here. In 6 minutes, here's the job, 6 minutes, this person can get 1/6 of the job done in 1 minute. So now we have how much of the job can get done in 1 minute, a quarter, how much of the job can get done in 1 minute, which would be 1/6 of the job, and then you say, well, how long does it take for them to do the entire whole job? So again, 1 minute, how much of the job gets done? In 1 minute, how much of the job can get done? And this number is the entire job. So it's a little bit confusing, but if you set it up consistently the same way, it kind of makes these easier. So now we can do the math behind this. We can find a common denominator to here, so let's just easily use the 24. So we'll multiply this guy by 4 or by 6, multiply by this by 6, and we get 6 over 24x. Well, times 4 there to get 4 over 24x. Now x is the time, right? And this has to equal to 1. These are like terms because they both have x, so we can add them together and we get 10 over 24. X equals 1. I'm going to move this up, shrink it all a little bit so we can see it a bit more. Now we have 10 over 24, x equals 1. To get rid of a fraction in front of it, we multiply by its reciprocal. It's 24 over 10. We multiply this side by its reciprocal of that, the other side, so 24 over 10. We're left with x on this side equals 24 over 10, which equals 2 decimal 4. Now, 2 decimal 4 is a good answer, but if you're talking about time, you're going to want to convert this to time. So 0.4 of an hour is going to be 2 hours and 2 minutes and 24 seconds. How do you do that? 0.4 times, there is 60 seconds in a minute, and that gives me the 0.24. So it takes 2 minutes and 24 seconds using the two hoses. We'll try another one and we'll see if that makes a little bit more sense. I'll clear all this first. So let's try number 2. Move all this up. So Andrea can deliver 500 handbills in 2 hours. Amber can deliver the same amount in 3 hours. How long does it take for 500 handbills? Now again, the 500 handbills, that's extraneous. It doesn't really matter. The job is how much they're doing. So person 1 can do it at a certain rate. Person 2 can do it at a certain rate. And we want to know how much does it take for the entire job, which we consider one whole job. So the first one, in 2 hours, she can do the whole job. How much can she do in 1 hour? Half the job. We're going to add, in 3 hours, this person can do the whole job. How much can they do in 1 hour? A third of the job. So now we have our fraction set up. We will have our common denominators of 6. We'll use our fraction skills. If I had them, here they are. Okay, and we're going to rewrite that as 3 over 6x plus 2 over 6x equals 1. We have like terms. They're both x's. Remember, x is time. We can add those together to get 5 over 6x equals 1. To get rid of 5 over 6, we multiply by its reciprocal. These guys cancel. We're left with x equals 6 over 5, which is 1 and 1/5. And a fifth of an hour is 1 hour and 12 minutes. So together, they can do it in 1 hour and 12 minutes. So we'll do number 3, and then I'll let you work through the rest, because they're all kind of the same once you get the hang of it. I'll clear all this, so I'm going to pause it. I'll clear all the writing, and then we'll get back to number 3. Okay, starting on number 3 here. Mario can take inventory in the store for 30 minutes. His partner Carmen can do it in 20 minutes. If they work together, how much? So again, we have person 1 at a certain rate, person 2 at a certain rate, and how much for the entire job, which we classify as one whole job. The difference with these problems is the 30-minute one. Now, there's a couple ways of dealing with this. Because they want to know how long it's going to take, sometimes I just say, well, how much can they do in 1 hour? Or how much can they do in this situation? So we'll do the same thing again. Now, before, instead of doing the 2 hours, you could say how much of the job can they do in 1 minute. So in the first situation, they can do the job in 30 minutes. So in 1 minute, they do 1/30th of the job. Plus, in 1 minute, they can do 1/20th of the job. You just take 20 minutes, they can do the whole job in 20 minutes, and you cut it up into 20 equal groupings, and they can do in 1 minute, they can do 1/20th of the job. This equals one complete job. There's a different way of doing this, and we'll show you that one as well. So now you're going to do your common denominators, probably going to be 600. So you'll go times 20, times 20, times 30, times 30, and we get 20 over 600 x plus 30 over 600 x still equals 1. We have, just like polynomials, we can add those because they're like terms. We get 50 over 600 x equals 1. You're going to multiply by the reciprocal to get rid of the 50 over 600, so 600 over 50 cancels these guys out. We're left with x on this side. 600 over 50 will give me an answer of 600 over 50, and when I reduce all of that, I get 12 minutes. So it does work out. You can actually do it this way. There is another way of doing it, so I'll move all this up and I'll show you another way. The exact same idea. I find this sometimes a little bit easier when I'm dealing with things less than a minute. I say, if it takes 30 minutes to do the job, how much of the job could they get done in 1 hour? In 1 hour, this person can do the job twice. And this person could do the job 3 times in 1 hour. So we have a complete job. So this will be the same idea. We'll have common denominators, or sorry, not common denominators, like terms, add them together. We get 5 over 5x equals 1. We want x by itself. Divide by 5 on both sides. And then we have x equals 1/5. Well, 1/5 of what? This is how much of the job he can get done in 1 hour. So this answer here will be 1/5 of an hour. So 1/5 of an hour is 1/5 times 60, which is 12. And you get the same answer. So either way is fine, as long as you kind of understand what's going on. This way is kind of the same for each one. This way is if you understand a little bit better. It's essentially is how much can you do in an hour, how much of the job can you get done in a certain time frame. You set them equal to each other, add them up, and you figure out how much they can do in 1 hour, or the whole job, And hopefully that will work out for you.